students, welcome to this lecture. In this lecture, we are going to discuss a very important topic in your structure of the atom chapter. That is the uncertainty principle. The uncertainty principle, as given by the Werner Heisenberg, is a very important breakthrough for the structure of the atom, for formulation, or you can say development of the structure of the atom. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So today's video is the uncertainty principle. In the year 1927, the great scientist Werner Heisenberg proposed the uncertainty principle. Uncertainty principle is basically the consequence of the two things that we have already discussed in our previous videos, in the previous lectures. That is the dual nature, that is the wave particle behavior of the matter and as well also the radiation. Both matter and radiation, they will have that dual nature, and this consequence, as a consequence of this behavior, the Heisenberg gives this uncertainty principle. So what is uncertainty principle? What is uncertainty principle? Uncertainty principle is basically, it states that it is totally impossible to determine simultaneously the exact position and momentum or velocity of the electron. That you cannot able to determine the velocity and the position of this electron simultaneously, and this he has been expressed mathematically like this way. Mathematically expressed this as del x into del p, that is greater than equal to h by 4 pi. And when we put, this is basically del x is the uncertainty in the position. Uncertainty in position means when del x will be higher, there will be the uncertainty in locating the position of the particle. When del p, that is uncertainty in momentum. Uncertainty in momentum, and del v is the uncertainty in velocity. So these are higher the value of this del x, and higher will be the uncertainty, that we cannot able, we are not certain about this position. When higher the del v means we are uncertain about the velocity of this object. So this will give you can able to calculate the uncertainty when a object is in the motion. by calculating by using these relations. And this is how he states the uncertainty principle. Okay. Now let us understand what it really means. It really means that when we are able to know, it is known the position of the electron more accurately, more precisely, then we cannot certain about the position, velocity of this object. Conversely, when we know the velocity of the matter, velocity of the particle more accurately, we can able to calculate it more accurately, then we also again not certain about its position. So for the electron, as it is a very microscopic, you know its mass is very less, it is almost zero. 9.1 into 10 to the power minus 31 kilo means it is almost zero. So when we are going to locate, we are going to see physically that I am here, you see me physically that I am here. In the same fashion, we are going to see the electron physically. What we will found? We will found a very blurred picture. Very blurred picture. You could not able to understand its position or its velocity. And that is what the uncertainty principle is called for. So we can now try to understand what is the applicability of this uncertainty principle for the macroscopic object. Macroscopic object means 1 milligram, any body that we are able to see, and microscopic object, that is like the electron, photons, neutrons, all the microscopic object. So what will be the uncertainty for this macroscopic object and for the microscopic object? Mathematically we want to understand now. Suppose 1 milligram of a substance that is moving at a speed of 100 meters per second, then what will be its uncertainty? This is the formula that we have to use every time for measuring the uncertainty. So you can see Max Planck's constant is this 6.6 in 10 to the power minus 34 divided by 4 into 3.14 into M is given here 1 milligram means 10 to the power minus 6 kilo. So what we will find, you can, this is approximately 10 to the power minus 28. If we put this value 10 to the power minus, this approximately, we are not taking this value, which will be some value. So you can see the uncertainty for the 1 milligram mass when it is moving at a speed of 100 meters per second, its uncertainty will be only this, very less uncertainty. Means what? We can able to calculate its position, its velocity simultaneously. So we can able to have a very clear-cut trajectory, clear-cut path of this object, of this 100 milligram substance, because it is having a substantial mass. Now we see what will happen for an electron. Suppose electron is moving at a speed of suppose of 1000 meters per second. Suppose, then what will be its uncertainty? So what we see, the uncertainty is 10 to the power minus 4, much more than this value. Means there is a higher amount of uncertainty. So the product of this del x and del v is higher amount of uncertainty. Suppose we calculate, we are able to calculate the position at 1 angstrom level, means 10 to the power minus 8 meter. With that accuracy, with that uncertainty, okay, 10 to the power minus 8 meter position of the electron. Then what will be the uncertainty in your velocity? That we put this value 10 to the power minus 4 divided by 10 to the power minus 8, it will be coming around 10 to the power 4. You can see how much uncertain the position and velocity of this electron. So you can easily understand, for a microscopic object, this uncertainty plays a significant role. Heisenberg uncertainty principle is giving a lot more significance, lot more meaning for the microscopic object. Why? Because its mass is very, very low. You can see 9.1 10 to the power minus 31 kilo. So this has been converted into a uncertainty in this velocity, where we are able to calculate the uncertainty 10 to the power minus 8 meter. So why it is so? Let us first understand. And what is the significance of it? First let us understand. Significance of it, that it is ruled out any exact path or any trajectory for the microscopic object of the electrons. Any trajectory, for know the trajectory for path of any object it is in moving, what we need to know, that is the velocity or position of that object. For the any macroscopic object, we can able to know its position and we able to know its velocity at any instant, and after some time also we can able to calculate, because if from this value we are able to calculate the force acting on that object. So there you can able to calculate the trajectories of a definite well-defined path. But for the electron, as because we are not able to understand able to calculate the speed and the position of this microscopic object simultaneously. So how can I able to make a trajectory? So it is almost impossible, it is almost ruled out that we will have a definite path or trajectory of a electron. So what it comes out? It comes out when Bohr says that electron is moving in a definite, well-defined circular orbit in around the nucleus. What does it mean? It is not possible, because when we are saying that electron is moving in a well-defined path, means we know at any instant its velocity and its position. But as per uncertainty principle, it is not possible. You will only know one thing at a time. So these things is not possible. What is in the Bohr model, Bohr has propounded that is not possible. So from this term we will go in this term of probability, that is probability of the finding electrons in a particular place. That we will discuss in the quantum mechanics afterwards in detail. So you now understand what is the implication of the uncertainty. Implication of uncertainty is that it is ruled out any fixed path or any fixed trajectory of the electron. Now question arises why it is so. That we can understand now. When we want to see any object, what we do? We do make some light on that object. That is why we are able to see this. And for the electrons, suppose this is the electrons. Electron is a very minute particle that we cannot even see in the naked eye. So when we want to see this electron, we have to, and one thing, that when we measure one object, that we have to use a scale, that is, the dimension will be less than this. So when we want to see this electron, we have to use a wavelength. We have to use the light. We have to use the light having the wavelength less than this. That is how we can able to see. That is, the wavelength will be less than the dimension of this system, dimension of the object. So electron is a minute particle. We can able to see a spot. So when we want to see, for locating, for know the position of this electron, we have to see it. And how can we see? By using this light. This light is having the lesser wavelength than the dimension of this. So you will know that lambda is h by mv. So when this lambda will be less, then mv will be very much higher. mv of the photon will be very much higher. So with this high momentum of this photon, when it will collide with this electron, you can understand easily what will be its speed. So if we able to know the position of this electron very accurately, but due to the high momentum of this photon, you do not know about its velocity. Its velocity will change, and that is why there is an uncertainty principle comes, that you cannot able to determine simultaneously both the position and the velocity of the electron. And that is the very fundamental thing. And the next video we will discuss about the quantum mechanical model of the atom. At that time we will understand how this uncertainty principle and along with this de Broglie's dual nature help to shape up this quantum mechanics. Okay, now we want to clear this concept by doing some examples, some numericals. Okay, the questions that numericals in the form of numerical given. For a particle, it is found that uncertainty in velocity, that is meter per second, is reciprocal of the uncertainty in the position in meter. The mass of the particle will be fixed, a variable value, a value not greater than a particular value, value not less than a particular value. That you have to determine. For that, what we will do? We know the equation del x into del v is equal to h by. Here what is given here, del x, the uncertainty in position, the uncertainty in the velocity is the reciprocal of uncertainty of the position. So here given del v is equal to 1 by del x. Okay, so we can put it del x into 1 by del divide, that is, this uncertainty is reciprocal of this. So we get this h bar 4 pi m. So it is coming around m is equal to h by 4 pi. So what is this? This is a fixed quantity. We know this is a constant, this is a constant, this is a constant. So write answer will be a fixed value. Okay, this time what is the minimum amount of time required to measure the kinetic energy of an electron with a speed of 100 meter plus minus 1 this. So from this you can get a uncertainty in the speed, and for this you have to see the uncertainty in the energy. That is where uncertainty on the position, uncertainty in the velocity, uncertainty in the momentum you observe. Heisenberg's another principle is we have to apply, that is the uncertainty in the time and uncertainty in the energy, and that is given by H into M. So from this we are able to calculate H by 4 pi, and from this we will able to, first we have to calculate this uncertainty in the velocity, and this we can calculate that del V is equal to your 1 by m v2 square minus 1 by v2, this is v2 square, v1 square. So here v2 is what? Now v2 is 101 and v1 is 99, and from this we will calculate this. Afterwards we will put that, we will get this uncertainty in the del t, and that will be the minimum amount of the time required, and it will be coming around 0.3 seconds. Okay, that is all for the today's lecture. In this lecture we understood what is uncertainty principle, how uncertainty principle comes, what is the reason behind it, because electron is a very microscopic object, and that is why for this uncertainty principle is much more significant for the microscopic objects, not for the macroscopic object. It is not significant impact on those things because of they have the higher mass. So that is all for today's video, and we will discuss the next video, that is the most important part, that is the quantum mechanical of principles of the atoms. How the modern concept of the atomic model comes, that we will discuss in that video. If you like this video, you can share with your friends. I hope you have enjoyed this video, and thank you very much for listening. Okay, thank you.